Alright, so yesterday we actually stopped by submitting the code. We didn't have a chance to submit the code because we had internet outage. So I actually copied it and then submit, and it get accepted. So now we will continue with the next one. So I think the next one is temporarily unavailable. Or is this the last one?
3 friends.
3 friends is before this one. Okay, let's close this one. 3 friends. Okay, so first we are going to take a look at the problem. So as far as I remember, like we have 3 guys. They are located in different or the same location on the line, and their coordinates are always integers. And our objective is to move them either 1 position left or 1 position right, or keep them as they are, and minimize the distance between, pairwise distance between them. So is everyone clear with the question? Okay, looks like everybody is clear with the question. And then let's start thinking about how we can approach this problem. So first off, without doing anything, like we should understand how the problem works. So for example, if the input is 3, 3 and 4, what we can do is the guy that's at the location 4 can go back, like can go left 1 step, and then we don't have to move the first and second guys. And in the end, they are going to be all in the same location. So the distance, the total distance, pairwise, the total pairwise distance is going to be 0. And in the second case, we have 10, 20, and 30. So in that case, like this guy can go to right 1 step, this guy can go to left 1 step. And I guess like, would it make any difference to move this guy to the left or right? Probably not, because if we move left, we are getting closer to this guy, but we are getting further from this guy. And if we move right, then it will be the same thing. So if we stay on the same place, like all 3 cases, they are gonna end in the same situation. So, like here, you can start considering some different scenarios. Like what if the one on the left is the furthest from the others? What if 2 of them are on the same location? Like there can be many different cases that you might have to consider. But before doing that, like before making our if else branching, first we should consider how many different cases in total do we have. Like how many different moves we can possibly make with these 3 guys. What is the total number of possible moves? 27, right? Like basically for each guy, we have 3 different states. It can either go to left or stay in the same location or go to right. 3 times 3 times 3. So we have 27 different cases. And enumerating over 27 different cases, like it is the easiest thing, right? Like it's not like 100 million operations. So do we really have to avoid evaluating 27 different cases and do something more specific? Definitely not. Because we are running against time, right? And here, making only, like checking only 27 different states would be enough to get the correct answer. Otherwise, we are also increasing the risk of making a bug. Like, because many of you in the contest, you tried solving this problem with the specific cases. And in the end, for some reason, you were covering maybe 95% of the cases, but because of the 5% that was not covered, you get wrong answer. So to avoid that, like if total number of cases are very limited, as in the case of this problem, I suggest enumerating them all. Implementation is going to be easy as well. It's going to work super fast, and then you're going to get 100% accepted for sure. All right. So after this, after we realize that it's actually easy to enumerate all the 27 different cases, we are going to start implementation. And so before that, I'm just checking the input format. So in the first line, I get number of inputs, number of test cases. And in the following n lines, we have 1 test case that represents location of 3 people. Like the first guy, the second guy, and the third guy. And as an output, we should just write 1 integer that represents the total pairwise distance for that given input case. So I think we have all the information we need, and now let's continue with the implementation. All right. Like first, we are gonna read number of test cases, and then we are gonna have a for loop that is counting up to the number of test cases. And right now, we need to read each input test case. So I'm gonna say post 1, post 2, and post 3 for these guys. And after that, I actually don't need anything else to solve the problem. So to keep the code clean, I'm just going to write solve function, which is going to get post 1, post 2, and post 3. And it's going to return me the minimum pairwise total distance for the given positions. And then I'm going to print an end line. And that will be it. So now I'll go ahead and implement the solve. So before doing that, like one thing that is super important is to check the return type. Because even if everything is integer, the total pairwise distance might not fit into integer, right? So that's why we have to be careful with the boundaries. And here it says, oh, that's exactly the case. All the coordinates are between 1 to 1 billion. But if we get the total pairwise distance, it can actually go above 2 billion, right? So that's why our return type should not be integer, but it should be long int. And as you see, like we could have easily missed this point. So that's why it's very important. Like when we say you should be careful about the extreme cases, it's not just about testing your code with these extreme cases, but it is also about whether the result you are calculating is going to fit to integer or not. Like what was our first lecture about? In the first lecture, we solved different types, right? And like how big of stuff they can fit in. Because it's very important. If you know that, then you're not going to use the wrong type. But if you don't know that, then you can use the wrong type by mistake. And even if your logic is correct, you might get wrong answer because of overflow. So let's go back to our code. And instead of integer, we are going to return long int. And we have 3 integers, position 1, position 2, and position 3. And we will be enumerating them all. So we need like basically 3 for loops. Like for each case, basically I have 3 states, right? I can either go left, which is represented by -1. I can, like alternatively, I can stay as on the same position, then it is represented by I equals 0. And finally, I can go to right by 1 step, which is represented by I equals 1. And I'll do the same thing for J and K. Oops, this is going to be -1. And after that, basically, I am going to update my positions and then calculate the pairwise distance on top of that. So here, like, I used I, J, and K for the dummy variables. Like, since these variables are almost always used in the for loops, they are called dummy variables. And I highly recommend using those variables in your for loops, but nowhere else. Like, if you get a parameter called I, then people are going to get confused. Because whenever it is read in the function block, people are going to think that it is actually a for loop variable. But indeed, like if you take it as a function parameter, it's not a for loop variable, right? So that's why I highly recommend avoiding using IJK out of for loops. And in the for loops, like you can use more meaningful names. Like here, instead of IJK, we could have used delta 1, delta 2, delta 3. It doesn't matter much, but not using IJK out of for loops, this is an important concept. Because other people who read your code, they are going to think that these are dummy variables. These are used in the for loops. And if that's not the case, you are actually misleading the reader. And after we calculated the new positions, all we have to do is to check the pairwise distance. And we are going to say long int total distance is equal to absolute value new post 1 minus new post 2 plus absolute value new post 2 minus new post 3 plus absolute value new post 1 minus new post 3. And after I calculate the total distance for this case, what I'm going to do is I'm going to check it against my solution. So first it has to start from such a large number, right? So that we can take it down to like one of the valid results. So that's why I'm going to check like long int max value C++. Okay, L long max is what I'm looking for. What is going on? Okay. And if the total distance is smaller than the solution, then I'm going to update the solution. And then I'm going to return the solution. So the type of solution is long int. The type of total distance is long int. And at this point, I don't expect to have overflow. Let's give it a try. Okay. Maybe we have to include this guy. Oh, this is for C. Okay, I can just include C limits. Give it a try again. And let's just copy the sample input. Where was it? Oh, it was here, I think. Copy. Oh, there's no paste. Oh, yeah, we had this yesterday. It's this guy. So let's try the first 4. Oops. Three, 4, 10, 20, 30, 5, 5, 5. 3, 4, 10, 20, 30, and 5, 5, 5. So the second one was 36. I think that is correct. So let's give it a try with this case as well. Like 1 billion, I think. Let's run it again and say 1 billion. And 1 billion. Okay, let's see if it's correct. Yes. So at this point, since I was careful with the long int thing, and I tried some extreme cases like where the result is 0 and where the result is big, I am confident that it should probably work. So that's why I'm gonna submit it at this point. But like normally, you might want to try a little more test cases. Like since I had some experience with the problem and I already code the case where we can have overflow, I'm not going to try any other inputs at this point. We don't have a file. Let's go to submit code. Copy our code from here. Choose a problem with reference. Copy our solution. Submit. think we can get back to this later on and start working on the next problem. So, yes.
Do we actually need the long return type here? Because the maximum total pairwise distance could be 2 billion, I think, and 2 billion doesn't pass.
Is it 2 billion? I mean, if it's 2 billion, then yes, it is enough.
Okay, it's 2 billion, I think.
Okay. If the total, yeah, if it's 2 billion, then it's enough. And if not, like, and if you're not sure, then it's better to use long end. Yeah. Yeah, I wasn't super careful with that, so it's just I played it safe, but like, yeah, mathematically it might be less than 2 billion, right? Like.
At max, it's like 2 billion minus 2, I think.
Oh no, I don't. I think it can be bigger than 2 billion. How about this case? Like you have 1 billion, and half a billion. So between these two, you're gonna have 1 billion, right?
Yeah. Another 2 is.
And actually, you're right. So it's gonna be like in total 2 billion. Okay. I think you're right. Yes. Yes. All right. Cool. So let's continue with our next problem, which is it shuffle hashing? And I guess after that we have temporarily unavailable. Okay, so let's continue with shuffle hashing. So in this problem, for each input we are given 2 strings. Where is it? So here, like for each input case, we are given 2 strings. And what we are asked is whether any anagram of the first or any permutation of the first string appears in the second string or not. So like it obviously it has a story behind, like it says something with passwords and stuff, I guess, right? And like no need to discuss that part. Like at the end of the day, once you get the essence of the problem, it turns into checking whether the first string's any permutation appears as a substring in the second string or not. And in order to check whether one string's permutation appears in the second string, what we can use is we can basically check the letter counts. Because is it possible to have a permutation of one string by changing the letter counts? No. The letter counts has to be equal so that this substring will be a permutation of another string. So that's why the way I would approach this problem is I would start from the beginning plus the length of the first character. And then count all the letters in the first part and update these counts based on the appearance of the first. Let's say if the length of the first string is n, for the first n character of the second string, I will update the counts. And then check if the count values I have is equal to the count values that is desired by the first string. And if that is the case, then we know that there is a permutation, so we are going to print out yes, I think. And if that is not the case, we will continue checking the following substrings. So if it is not the first substring from 0 to n, then I should check from 1 to n plus 1. And after that I should check from 2 to n plus 3, and so on. And the string lengths are up to 100 characters, I think. So like based on these thresholds, our implementation should do okay. So because our time complexity is, first we are going to calculate number of counts of appearance of each letter. And after that, to check the equality, we are going to be going over all our counts array. So basically the time complexity is going to be 26 times n. Meaning n meaning the length of the first string. So is everyone clear with the solution we have in mind at this point? And is there any other solution that you want to suggest which can be simpler than this one? I mean, there might be one, but at this point, let's say you are in a contest or an interview and you have a good working solution. Instead of searching for a better one, at that point, it's better to implement it. And after that, you might be prompted by the interviewer, hey, can you do it without using extra memory? Can you do it in linear time, or can you do it in logarithmic time? You know, they can prompt you for a better solution after you have something working. but it's important to have something working in hand at first. And when it comes to competitive programming, if you are comfortable that your solution is going to get accepted within the boundaries, then there is no point in looking for a better solution. So, right now I will go ahead and implement, and before that now I'm checking the input format. So in the first line we have the number of test cases again, and in the following 2 lines we have 1 test case, and that is the case for all the following 2 lines. So basically, like in the first line I have AB, AC, ABA, and in the third line we have Z, Y, X, and then a permutation of AB, AC, ABA, and then BK, JH. So I will be checking whether the second string has any permutation of the first string. So we collect all the information that we need. Now let's go to implementation. So we are not gonna eat the sol. Here we will need an, and then we are gonna be reading some stuff. Yes. So for each test case, we are gonna be reading 2 strings. Therefore, I will define 2 strings here. 1, 2, and then I will say input 1, input 2. So after reading these, again, I am going to use a similar structure to the previous problem. So I'll call the sol function. It's going to get 2 inputs, and then it will return either yes or no as a string. And then I'm going to print out the result to the screen. So now let's go ahead and implement our sol function. So first, what we are supposed to do is we need to find the desired counts for input 1. Desired counts, and I'm gonna get like an array in size of 26, and I want it to be filled with zeros. And then we are gonna update the desired counts corresponding character, which is input 1.add minus a, and I'm gonna increase it. So at this point I should have the desired counts. And here, like, it's better to check whether it is working as expected or not. So I'm going to print out them. Like, you can make use of this practice in the contest environment often. Whenever you finish a small logic of code that you finish, please do check its correctness right after. Because if you do that, you basically decrease the risk of making bugs in the end. Like, it's as if like you are testing each unit separately, and once you put them together, it's more likely that it's going to work without a problem. And if you don't check these small units at the beginning, and once you put them together there is an error, then you have to go back and look each of them, because you don't know where the error is. So that's why it is highly recommended to check every small logic block that you implemented and see that it's working. Like, it's going to cost you maybe a minute or 2, the most. And for our interview preparation purposes, this is nothing. And even in the context environment, right now we are not competing with the best of the best, right? So the seconds are not super important for us. So that's why I highly recommend applying this practice. So check every single small unit right after finishing it. All right, so let's also return an empty string for now. And let's give it a try to see whether our counting for letters for the first string works or not. So I'm going to say there will be only one test case. And the first string is AA, BBB, C. The second string is not important. And I would like to see the output. So it says 2 A's, 3 B's, and 1 C, and the rest is 0. So it is working as expected. Therefore, now I can confidently continue with the next steps, and moving forward, I don't have to worry about this part anymore, because I know that the desired counts are calculated correctly, right? So no point worrying about this part anymore. So once I have the desired counts, what am I going to do is, first I need to initialize the counts that comes from the second input. So actually I can use the same for loop. Like at the beginning I didn't think about that, but the first substring that I'm going to check against the first string from the second string is like its length is actually equal to input 1's length, right? So here I can actually update the counts array. So it's going to be very similar to desired counts. We're going to have 26 cells in our counts array, and then it's going to be initialized with 0 as well. So in the counts, instead of input 1, I am going to do the updates from input 2. Input 2 dot at I dash minus a plus plus. So at this point, I already have the counts for the first substring of input 2. So I'm going to start my for loop, and I is going to start from 1. And I is less than input 2 dot length minus input 1 dot length I plus plus. So at the beginning I is 1, meaning it's going to consider the first character as, no, I think it's better to start from 0. And if they are equal, do I want this for loop to be executed? Yes, let's say less than or equal to right now. So we are going to decide on these boundary cases later on. But here what I'm trying to do is, like basically I will simulate the operation of moving in the second string. Let's say my first string is ABC, and then my second string is CBB, ACB. So here, like first I'm checking ABC against CBB, right? So this is going to be my start, this is going to be my end at the beginning. And then after I do the check, I see that they are not anagram of each other, I'm going to move them by 1. So end is going to come here, and start is going to come here. So basically here I'm trying to decide up to what point this start should continue. Actually here I can do this. Check equality, and then I'm going to give counts and desired counts. If this is the case, we are going to return yes. If this is not the case, then we are going to start from, let's say 0 for the start, and then it's going to go up to input 2 length minus input 1 length, because these are all valid remaining start points. And then I'm going to say I plus plus to update the start point. So let's actually make this start. It can start from 1. If it starts from 1, then in case of equality, I don't want this to execute, but in case of input 2 length being 1 larger, so I need equality here. So yes, what I'm going to do is, I'm going to drop the count from start minus 1 from counts array. So what it means is, like because we are moving forward, right, our new start is 1, and previously our start was 0. That's why I need to decrease the appearance count of the character that is right before the start. So is everyone clear with this statement? Because I'm moving my substring 1 right? So previously it was starting from 0. And right now I want to consider the substring that starts from 1. Therefore I drop the first character, which is the 0 character of the second string. Is everyone clear with that? The statement? Okay. And that's not the only thing that I should do. The second thing that I should do is basically adding the last character, right? So I'm going to say count input2 dot add, like here basically we can say like end is going to be equal to start plus input1 length minus 1, I think. Let's think. So initially the end character is input1 length minus 1, and after that, once I move it 1 to the right, I want it to be input1 length. So start is 1, minus 1, and 1 is going to take each other out, so it's going to be input1 length. I think this is correct. And after that, I'm going to say counts input2 dot at end plus plus. And after I do the update, basically I'm going to use the same logic here. I'm going to check them for equality. And if they are equal, I'm going to return race. And if they are not equal, then I will continue searching for equality. And finally, if I couldn't find any equality up to this point, it means I checked all the substrings and there is no equality. So I have to return no here. Like as you see, like we approach the problem top down. We divide it into different logic units, and then after we finish implementing one, we go to the next one. Like this way, everything is clear about how I'm gonna start from the beginning and then approach to the end desired solution. So the last remaining piece for this code is implementing check equality function. And as you see, instead of implementing this as a function, if I just wrote it here, then I had to copy the code again here, right? And since now I write it as a function, the code is gonna look way cleaner. I don't have to repeat the code again and again. So that's why, like, feel free to divide your solution into logical blocks and define functions. And this is also desired in the interviews. Like, if in the interview, if you write the code like a competitive programmer, you're not going to get very good feedback. But if you write it clean, if you write things with logical blocks, with good naming, then you're going to get better feedback. And finally, this function is going to be a Boolean function, check equality. And then it basically gets two integer arrays. Let's say counts 1 and counts 2. And then what we are going to do is, I know that their length is 26. So that's why I'm going to do my for loop like this. If counts 1i is not equal to counts 2i, then we are going to return false. And if we reach the end and we couldn't find any inequality, it means we should return true. So now let's give it a try. So let's go to our input case here. Since I'm not able to copy to there, let's write our own input. So let's say 5, and first we have AB, AB, AC, and then we have something, and then AC, BA, BA, and then something. So for the first one, we expect the answer to be yes, and the answer said no.
Forgot to add minus a at line 29.
At line 29.
No, down there, sorry. 38.
38. Oh, yes. Thank you very much. Okay, so let's stop. Yes. Okay, so now let's give it another try. I mean, as you see, like, you can have bugs. That's completely normal. Nobody expects you to write a code in the first trial without any bugs. But what you should do is you should detect those bugs and then fix them and then reach to the correct solution. So let's say we are going to try 3 inputs. The first one is AB, AB, AC. And then we have something. And then CA, BB, AA. And then something. And the answer is yes. And let's say one no case. Let's say we have AAA, 4A, and 3B. and then in our string we have 3a and 3b. What if like our string is shorter? Whether it's gonna work or not, we will see now. Okay, so we had trouble, but now we can check whether they like the second string should have at least as many characters as the first string. Is there such guarantee in the code, in the problem? Okay, so it doesn't say anything about that. So that's why we have to consider this case. Like as you see, by trying an edge case for our program, we actually find a case where it is not working. So now we should go ahead and fix this. Like basically this is an extreme case where input 2 is shorter than input 1. So on top what I'm going to do is if input 2 dot length is less than input 1 dot length, then I'm just going to return no. Because there is no way we can have the input 1 as substring and input 2 if input 2 is shorter. Okay, so now let's give it a try again. Let's say we are gonna try two cases. First, let's try the first case, like input 1 is longer than input 2. It says no now, it doesn't break, which is good. Now let's consider a case where the length is equal, but there is no substring. So let's say we have AAA, and then we have AAB, AAB, BB, AABB. And the answer is no. Okay. So is there any other extreme case that you guys might want to check for such problem? I guess like we considered some extreme cases, right? Input 2 is shorter than input 1. And some yes answers, some no answers. So at this point, I'm going to go ahead and do the submission. And let's just check our input one last time to see if there is, like for example, if there is any empty string case, for example. No, there is no empty string case. And let's also make sure all the characters are small letters. Lowercase Latin letters. So we get confirmation for that as well. And I think we are ready to go right now. So let's click on submit code. Let's copy our stuff from here. It's shuffle hashing, I guess. And let's say submit. Okay, by the way, oh, beautiful string, we have already seen this one. What else did we send? It's problem. Three friends. Okay. So we get accepted for shuffle hashing as well. Let's open 3 friends again. Okay. It says Happy New Year. I guess this means accepted, right? Okay. All right. So far, do we have any questions? Like as you see, once we divide it into small logic chunks and then test everything, still we can have bugs. Like Murat pointed out that I forgot taking out the value of character A. But that's very normal. After you give it a try, you're going to see that you get wrong results, and then you are going to look back at your code, and then you're going to pinpoint where your problem is. But if you want to decrease the time that you're going to spend with debugging your code, it is highly recommended to divide it into small chunks and then test each chunk right after you finish implementation. Because this way, like, you know where exactly to look for. Like if there is a problem with connection of all the small logics, you're going to see the problem in the end and you know where to look for. But if you don't test anything and then in the end you get the wrong answer, then everywhere, the bug can be everywhere. Okay? So that's why it's very important to finish the small logics first, debug, test them, and then connect them. Okay. Any questions up to this point? If not, we will continue with the next problem, which is, yes. Okay, I think that's enough. Like we covered like 2 questions right now, right? Okay, let's do that. Let's take a minute of break then. Okay, mine's here. So what do you guys think about this kind of problem solving sessions? Like, do you guys think that it's valuable? Should we also do this for a little harder problems as well? Okay. So, like today I will keep it with problem A because the first point that we want to reach is like we want everybody to get the first question of these two comfortably. Okay? And moving forward in the next sessions like this, I will also cover harder problems. Like how, in that case, we are going to spend more time on the whiteboard to come up with the solution, and then we will go ahead and implement it. So let's make use of this time and check the progress. So thank you very much for people who uploaded their code and updated the links here. This is going to be super useful moving forward when we get the coverage like column-wise and row-wise coverages. So if you didn't do it yet, please go ahead and do that. The earlier you do is the better, basically. And let's go to peers. Is Donny here? Donny. What is your preferred language? Java? Okay. And Frey is not here. Yeah. Let's see. Meron? Not here. Kaleb is not here. Ermias is not here. Akayo is not here. I think these are third years. Let's put it here. Let's put it here. Nabek, is Nabek here? No? Bontu? It's not here. El Shaddai? Not here. Not Nile? Okay. Let me know when we are ready again. See you guys. Okay. All right. See you guys. Have a nice weekend. Almost. So in the meantime, I can demo a couple things to you guys. So the first one is, maybe I already mentioned about this, but if you didn't hear about it, so there is this extension, Chrome extension called Momentum. So I find it very useful when it comes to like adding my to-dos as well as like the main focus. So it changes the code you have here in the bottom every day. Like today's code is don't let yesterday take up too much of today. So every day it shows you a new code. At the same time, it changes the background photo. And every time you open a new tab, like you basically see this. And since today is a weekend day, like I wasn't making use of the to-do list and focus. But especially in the weekdays, like I find it highly useful. So I highly recommend. It's called Momentum. If you just type Momentum extension to Google, I'm pretty sure it's gonna come up. Momentum extension Chrome, or I think it's also available for Firefox. I like it a lot. So the second thing I want to demo is, like with some of you, we already talked about this. Like if you have a packed schedule, like mine, without having calendar, like there is no way you can cope up with everything. Like you are going to be missing a lot of meetings. You are going to forget about exam dates, project deadlines and stuff. And actually Google Calendar is super useful. So you can create some recurrent events as well. Like our one-on-ones are examples of that. Likewise, like you can mark your classes, you can mark your deadlines. This way, like you can have way more organized life. And if you want to get more things done in the same amount of time, I highly recommend being well organized and using calendar. Like frankly, I wasn't making use of calendar until this year, and I see a very big difference. So if I have a chance to, like, I think we had such question, right? I didn't think of that at that point, but one of the advices that I would give to my younger version is start using calendar early. Yeah, like it definitely helps you to increase your productivity. And also, a couple warnings about that. Like if you have something that you didn't do and then the time passed, just go ahead and update your calendar. Either reschedule it to sometime future if it's something that has to be done. Let's say you need to prepare for the midterm exam and you couldn't do it for some reason, but you have to prepare anyways, right? So just reschedule the event as we do for many of our one-on-ones, and like make it so that like the past actually represents the reality. Okay. So for example, today I didn't have the morning workout, so I'm gonna delete this event. And likewise, I couldn't have one-on-one with Suha, so I'm gonna move it to tomorrow. Like this way, when you look back in your calendar, the calendar is gonna represent reality. And that way, like your current version, your previous version, and your future version, they will be all in sync and harmony. Because like you are creating all these events and you are putting them on your calendar, right? So you are responsible to yourself. You're not responsible to someone else. And if you get used to not feeling responsible to yourself, which can happen in case of not your calendar representing the reality, this is not a desired state. So that's why I also highly recommend update your calendar frequently so that it represents the reality. Like if you don't do something, if for some reason you skip something, that's not the end of the world. Like we all do that. That happens from time to time. But if it represents reality, like you can go back in time and see, oh, actually this week, like I did a lot of stuff. Oh, I didn't spend enough time on this project this week. Or, oh, next week actually I can improve on that. So that will be also helpful. And like in the long run, hopefully once you guys are academicians or like successful business people, obviously you're going to have more stuff on your plate. So far my experience in life, it never gets less tense. You know, it gets more and more tense. Like you get more responsibility, more stuff, so you need to make more contributions. So the earlier you start practicing into the professional life, the better for you. And you might see some other people, some other professionals who don't practice this way, and it's their way. I respect that. But the people that I know, they use organized life, and when they are organized, they get a lot more things done. And as a, like my personal experience was that way too. When I'm more organized, I get a lot more done. Are we still not ready? Man, I'm running out of topics. So I can also recommend a website. It is news.ycombinator.com. Have you guys ever heard of this? It's also called as Hacker News. So it's a very interesting community, mostly programmers, but like top programmers. And you find things from many different topics, like sometimes things related with genetics, sometimes things related with politics, but most of the time things related with technology. And the authors, they usually give their honest opinion. Like as you see, the user interface is not for anybody, like it's more for programmers, like text-based. And like usually I learn many interesting stuff here. So instead of reading news, I check Hacker News. So stuff here usually, it is, in my opinion, helpful in the long run. Like if you read just today's news, no matter what country's news you are talking about, in 1 week, at least half of it is not going to be used. In 1 month, 99% of it is not going to be used. But if you learn something that is going to be helpful even after 3 months, even after 6 months, in my opinion, it's a better use of that time. If you learn something that can affect you in the long run, obviously it's a good information to keep in your mind. And in Hacker News, usually they cover such stuff. Like a lot of stuff related with machine learning, a lot of stuff related with software engineering, a lot of stuff related with different problem domains as well, like new developing technologies. You can find posts about them. And also, it's not just about the posts. The comments are also very useful. Like, for example, let's find one. Okay, so there is an interesting one about Turkey. Turkey unveils first fully domestically produced car in 3.7 billion bet on electric. So let's see the comments. If you click on the comments, you will see like many comments, and they are actually sorted in the order of popularity. And by reading these comments, you can sometimes learn a lot more than the news. I mean, now this is a long comment. I'm not going to go ahead and read, but I think you guys get the idea. So not just check the post, but as well as like read the comments. Sometimes you learn a lot from the comments as well. Are we ready? All right. So in that case, let's go back to our competitive programming world and continue with temporarily unavailable problem. Yes. So like basically as it is illustrated by the photo, by the picture that's in the bottom, like in this problem, we are given 2 points. First, this is our start point and this is our end point. And our guy goes from start point to the end. And also we have one cell tower, like which is covering some area that may or may not intersect with the way that we are walking. So in the given example here, it is actually intersecting, fully intersecting. Let's make it a line. So our end point is 10, and our start point is 1. And the cell tower is located at point 7. And then its coverage is from 6 to 8. And here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the question is basically asking how many of these we have covered. Like during our walk, how many of the intervals are covered by the cell tower or not covered? I don't remember which one it was asking, but once we find one, the other one is also in our head. So for this example, it's 1, 2, 3, 4, 5, 6, 7. So like we are not covered for 7 cells, like 7 intervals. Which ones are not covered? Look, at the end of the day, this problem comes down to intersecting two given line pieces, right? If they are not intersecting, our result is the length of the first line piece. If they are intersecting, basically we are taking out the intersection from the first, the length of the first line piece. And this is our result for all the cases. So any objection to this proposed solution? And if we don't define it this way, again, we might have to struggle with solving many different sub-problems. Like what if I am walking from here to here and the cell tower's coverage is on the right? What if the cell tower's coverage is on the left? What if it is intersecting from the right hand? What if it is intersecting from the left hand? What if it is completely inside? Like I'm pretty sure some of you guys went with this solving these sub-problems, and in the end, again, maybe you covered 95% of the cases, but because of the 5% uncovered cases, you get wrong results. So that's why I highly recommend spending a little more time when you have such kind of a solution which has a lot of branches, a lot of sub-problems, to see if there is more generic, more general algorithm that you can apply and get the results in a cleaner way. Because if you are going through this path, you are going to consider like 6 maybe different problems. You increase the risk of making some bugs, plus you're not sure. Maybe there is one more case. What if they are exactly touching to each other? Is your code doing the right thing in that case or not? Like you wouldn't know. But if you define it in a generic way, like for this problem, if we define it as, oh, actually here we are given 2 line pieces, and we want to see like how many, like for how long they intersect with each other. If we define our problem this way, then we can only define one function, and with the help of that function, we can basically calculate the solution. Okay? So that's why it pays off to spend a little more time if you think that there are too many sub-cases, too many sub-problems. And this can be especially the case for the easy problems, you know? Like easy problems are usually easy for the experienced programmers, but they are not that easy, or there is a high risk of making bugs for inexperienced programmers. Okay? So that's why pretend as if you are an experienced programmer, because you are becoming one as doing more and more practices, and try to find generic solutions instead of one at a time solutions. The question? Okay, so in the question, what it asks you is, like we have one guy that is moving from point A to point B. Like for this example, the guy starts from 1, and then he is walking towards 10. And there is one cell tower. Its location is at 7. It is also given in the input. And the coverage of the cell tower is also given. And for this input, it is 1. And once we have a cell tower at 7 and its coverage is 1, obviously it is covering from 6 to 8, right? And the problem is asking, when we are walking from 1 to 10, how many of the steps we have, or like how long of this interval is not covered by the cell tower? Like basically here, the guy will be covered for 2 cells, and he will not be covered for 7 cells. Because from 1 to 10, we have like 9 cells, or like 9 intervals between 1 and 2, between 2 and 3, and so on. Is it clear now? Okay. So any questions up to this point? If not, and since we have a solution in mind, basically, we are going to write a function to find the intersection of 2 line pieces, and with the help of that, we will find the answer. Now, let's go ahead and implement. All right, so we are not going to need this code anymore. Let's remove this. And what is our input? Let's check our input. So in the first line, we are given number of test cases, and in the following n lines, at each line, we are given 4 points. So the first point is our start point, the second is our end point, the third is the location of the cell tower, and the fourth is the coverage length of the signal. So now let's go ahead and read our inputs. So we will have a for loop here, and we are going to be reading 4 numbers, and these are int start, end, cell tower, and coverage. Again, we can use a function like solve and give all the information that we have here, start, end, cell tower, and coverage, and it's going to return us the answer, and then we will print it to the standard output. So now let's go ahead and implement our solve function. So before doing that, let's check some extreme cases, whether the answer is going to fit to integer or not. So looks like it is between 10 to the power of 8, which is 100 million. So everything is between minus 100 million and 100 million. So in that case, I don't think overflow is going to be an issue. So everything is supposed to fit to integer. So that's why we can use integer as return type. Oops. Switch our tab. And we are going to implement our solve function. Solve takes start and cell tower location and coverage. Like basically here, what we want to do is we want to find the intersection length between start and line piece and cell tower minus coverage, cell tower plus coverage line pieces. So int intersection length is equal to, or we can just say intersection is equal to calculate intersection, and we are going to give start and end and cell tower minus coverage to cell tower plus coverage. And after we get the intersection, what is our result? Basically our result is end minus cell tower minus intersection, right? So now implement int calculate intersection. So you have int s1, int e1, int s2, and int e2. So now let's think about this intersection problem. Like basically, now we are given two line pieces. So they might be intersecting or they might not be intersecting at all. E1 and let's say S2, E2. So here, in case of intersection, like we are looking for this length, right? So it can be the case that the first line ends before the second line, or another case can be the first line actually ends after the second line. So it can be like this as well. S1, E1, and S2, E2. So this time we will be looking for this. So here in this case, the answer we are looking for is E2 minus S1. And here in this case, the answer we are looking for is E1 minus S1. So is everyone able to follow up to this point? Oh, this is S2, right? Thank you. E1 minus S2. Yes. So is everyone following up to this point? Cool. So now what we can do is, instead of handling these two cases separately, let's think about whether we can merge them or not. Because like, if we can merge them, then our code is going to be simpler, right? So here, did you guys notice something in common between two cases? Like which endpoint do we choose when we are calculating the intersection? Like the one that is smaller, right? Like here, E2 is smaller than E1, that's why we choose E2. Because there is no way E1 is going to be part of the intersection if E2 is smaller than E1, right? So actually the first thing that we see in common here is like we are basically choosing minimum of E2 and E1 as our endpoint for the intersection. How about for the beginning of the intersection? Maximum of the start points, right? So we basically take out maximum of the start points. Like once you think about it, it makes sense, right? Because we are talking about intersection. Intersection has to appear in both. So if one end is greater than the other, is there a point thinking about difference between the greater end and the lower end? No, because there is no way that part will be in part of intersection. Likewise, when we look at the thing from the star's perspective, is there a point taking the part that comes from the difference between the early start point and the later start point? No, because intersection is not started yet here. So that's why we get the maximum of these. So with this formula, we are able to represent both intersection cases in one place, which is good. Now let's think about this case. What if they are not intersecting with each other? What would this formula give us in that case? Like the minimum of the start points, the minimum of the end points is E1. And the maximum of the start points is S2. And if I decrease, if I take out this one from this one, what kind of number am I gonna get? A negative number, right? So basically, I can easily distinguish this case. If my intersection length looks negative, then I can say, oh, they are not intersecting, right? So looks like with one formula, we are able to handle this case. Now let's go ahead and write it. Min function in C++. Okay, it's in the standard library, so we can use it like this. Like what was our formula? Min E2 E1 minus max S1 S2. Okay, so if this is negative, then we want to say intersection is 0, right? So to be able to do that, we can actually make use of the similar function. Like we can basically say, get the maximum of this difference or 0, right? Because once it is negative, I want to return 0 because there is no negative intersection. And if it is positive, then I want to return the value as is. So, like we are done with the calculate intersection. We are done with solve. Let's give it a try. Like normally, you might want to test this logic. But right now, since there is not much that we have done in each block, like we can test it completely. But let's say in the context environment, if you're not sure whether your calculate intersection function is working properly or not, I also highly recommend test that as well. Okay, but right now I will skip that step and directly continue with testing with main cases. Okay, we have an error on 31. Okay, so we forgot this semicolon over here. Let's give it a try again. Okay, now let's get some input cases from here. 1, 10, 7, 1, 3, 3, 3, 0, 8, 2, 10, 4. Let's say we are going to use 3 of them. And 1, 10, 7, 1. 1, 10, 7, 1, 1. It doesn't look right, right? Is it 1? No, it has to be 7. So let's see. We have start and cell tower and coverage. So here we have start and cell tower minus coverage, which is 6. Cell tower plus coverage, 6 and 8. Okay, so now let's see. Let's debug our code. This is even better. Now we have to debug. So let's stop and then print what we get from intersection. So first off, we are going to print our start and cell tower and coverage. Also, I highly recommend
writing the name of the variables before you write them, like in case of debugging. So this is actually nice because we will also do some debugging practice. Like if you write 4 numbers and then you write more, then you're gonna mix like which one represents what. So that's why it's better to write them like this. Coverage. Okay. And after that, we can also print the intersection. And I think I see the bug right now. Here, instead of writing and minus start, we write and minus cell tower. But for the sake of completeness, let's go ahead and print our intersection as well. And finally, like since we see the output, like at this point, once I run this code, I think the problem is going to be visible because intersection is going to work well. Start and cell tower coverage will work well. And we will point our finger to, oh, something is happening at the end of the solve function. And let's go ahead and do this now. Excuse me. So start is 1, end is 10, cell tower is 7, and coverage is 1. But after intersection, oh, I put end. Oh, I said end. Let's make it end line. Because looks like we might still have some trouble. Let's give it a try. 1, 10, 7, 1. Okay, start is 1, end is 10, cell tower is 7, and coverage is 1. And intersection is 2. This is correct, right? Because the length of the second piece is 2, and it's completely included by the first piece. So that's why intersection length is correct. So yeah, like as we see output 1 here and everything else is correct, obviously it's going to tell us something is happening right after we calculate this intersection. And then it's going to, like once we look at the solve function, we are going to easily see that. And we are going to fix it. So now, and also one thing that I highly recommend, after you are done with debugging, but you didn't still get the confirmation about your final result, instead of deleting your debug code immediately, just comment it out. Because at this point, yes, I think it is correct, but I don't know for sure, right? So it's better not to delete it. Otherwise, like you are going to be writing it again, or you are going to press Ctrl Z, Ctrl Z. So it's going to take more effort. So it's better to just comment it out, okay? You might need it again. You already prepared it once. Because you might have to add, for example, if this debugging was not about the whole code, but for just only one piece, then you might want to keep it on. Maybe after adding the second piece, you might still want to refer to the previous debug code. So that's why, until you get to final confirmation, it's better to keep your debug code inside, just comment it out, and you can easily activate them in case they are needed. So now let's give it a try. Let's say we are going to try it. 4 inputs and then 1, 10, 1, 10, 1, 7, 1. Okay, so now we get the correct answer for this one, and the second test case is 3330. 3330. It says 0, and it is 0, and then we have 8, 2, 10, 4. It says -6. I think we get another point, another problem here, right? For 8, 2, 10, 4. Let's think about it. Start is end. Okay, so basically, if start is greater than end, it shouldn't be that way. So basically, we need to change the order. Okay, stop. And let's say. By the way, do you guys know how to swap two elements without using a temporary variable? If not, think about it. So for the sake of simplicity, I'm just using temp here, but there is a way to do it without using the temp variable. Start eşittir. Start is equal to end, and end is equal to temp. Okay, so let's give it a try again. Let's continue with our problematic input, which was 8 to 10 4. 8 to 10 4. So this time we get 4. 8 to 10 4. And I think that is correct, yes. And then we have 8 to 10 hundreds. 8 to 10 hundreds. 0. I guess that's correct too. And finally, let's try this guy. Minus 10, 20, minus 17, 2. Minus 10, 20, minus 17. Yes, and 2. And we got 30 for this guy, and it is 30. So at this point, like, we are confident enough about our solution. Now we are going to give it a try. Let's go to submissions. Oops, submit code. Temporarily unavailable. And now that we are submitting the code, we don't need the debug code anymore, so we can get rid of that. And then for the rest, we are going to copy it. We are going to place it here and then click on submit button. And it says accepted here, so I guess we can trust it. Yes. Okay. So any questions up to this point so far? I hope this gives you a good idea of how to approach to the easiest problem in Div 2. And obviously in the context environment, you are not gonna get to the solution this fast. So you're gonna spend more time on the paper. Like, since when you guys were taking this contest, I was also reading these problems and thinking about them. We were not under the same circumstances, right? I was more experienced. We already discussed solutions for this. So I knew what I was gonna implement. It is different than not knowing it in the context environment. But I think it gives you a good idea of how you should approach to the problem, how you should divide it into small chunks. Even for such easy problems, it's better to modularize your code and try to handle different pieces by very simple logics, by very simple units, and test them right after you write these, right after you implement these small units. Yes. Any questions? Not. Thank you very much.